it's a paper written around, and not just paper, they also did some testing as well. The concept called one-bit LLMs. It's going to be slightly technical, but I'm going to still try and hover at a 30,000 feet to help everyone probably follow. Uh, and so all of us are seeing the way Nvidia shares are skyrocketing, right? Like it went from 33 rupees per share, $33 per share in 2019 to $800 per share like yesterday, like 24x increase. Why? Because Nvidia produces GPUs. Uh, and what is the big deal about GPUs? GPUs are good at matrix multiplication. Matrix multiplication is the core requirement for LLMs for them to get trained. That's what the core mathematical aspect that's happening, the operation that's happening in the backend. And only GPUs can handle that level of matrix multiplication. What is matrix multiplication? Matrix is something all of us would know because we've done our studies. I mean, we learned it quite young, right? So matrix multiplication, nothing but taking one matrix, which is actually the weights of the model, and multiplying that with the another matrix, which is the input that we provide to the model. So this is when you multiply these two, you get an inference. That's the matrix multiplication aspect. That's what happens. So matrix multiplication can only be done. I mean, GPUs actually perform really well. Our CPUs are the ones that we find in our computers. They are not good because you don't have the capability to run so many parallel processing. So that's the whole concept of matrix multiplication. So what this one bit suggests is instead of in the matrix multiplication, ideally all the individual units are float, which is decimal points. It has like 0.34578 minus 0. Something. So it's float actually. So because of the float nature, the float, not an integer, the matrix multiplication just blows up and it needs more compute power. What this one bit concept is, hey, you know what? What if we get rid of all the floats and we will just have three types, -1, 0, +1, just three integers, and we will have the whole weights and input model just represented in these three integers. It will be either -1, it will be 0, or it's 1. That's it. That's a simpler way of explaining how they moved away from float to integer. When they do that, the necessity for multiplication, matrix multiplication goes away, and it's only matrix addition. And matrix addition needs lot less compute power. Lot less. When I say lot less, I mean crazy less compute power, which means you can now use your CPUs to run really highly efficient models. You can train the models, you can fine tune the models. So that is the whole revolutionary aspect about this one bit LLM. It was actually the first paper was launched last year in October, and the second paper was launched like last week or this week actually, which is taking the whole, I would say from the model trainer standpoint, it is kind of a crazy thing. And it's called as BitNet 1.8. The reason 1.58, because the introduction of 0, if it's just -1 and +1, you can call it as 1 bit, but it's not exactly 1 bit, it's 1.58 bit because 0 introduces the additional 0.58 element. But the fact that 0 increases the capability of the models to perform better, they went with this proposal currently. Let us look at the benchmark, the results actually. The best aspect about this is the latency, the throughput, sorry. The latency is has improved by 2.5x, but more importantly, the throughput is increased by 9x compared to Llama model. Okay. They compared with Llama, benchmarked with Llama. And that's what you mentioned in the previous thing, right? Llama is more like a benchmarking and prototyping platform. So they benchmarked Llama, and you know what? The throughput per second is about 3,000 compared to the best performing throughput that we have is Grok, which is doing about 500 per second. And this is 3,000 actually, which is 6 times better than Grok, almost 9 times better than Llama 2 actually, on the same, with all the other hardware and other stuff constant. So what 1-bit LLMs are kind of trying to tell all of us here is, this 1.58 BitNet is, you get better throughput, better latency, much smaller model, so you can run on your CPUs instead of GPUs, and this will actually start making the chip companies rethink their whole strategy on how they should look at doing the chip design as well. Because the moment you take the matrix multiplication out of picture, your chip designs might look very different because you just have to do additions. So that is why this 1.58 bit aspect is so revolutionary, because if this continues to move ahead in this direction, if more innovation happens in this direction, the idea of there is not even a small SLM, small language model. I'm talking about large language models can also run on smaller
Yes.
smaller hardware in the backend. So that's the whole concept about the 1.58 bit BitNet. The last point, it performs really well up to 3.5 billion parameters. So it is still not great for say 7 billion or 100 billion or a trillion parameters. So it is still hovering in that range, but it's a very interesting concept that has come out, and the benchmark results are also quite good. Some of the evaluation, you can just go and check the paper. It's available in archives. So some of the evaluation metrics that they've launched are pretty good as well. So that's the 1.58 BitNet news.
No, in fact, I think this could be a very good update. Thanks, Shiva, for sharing that. First of all, I think this could be one of the biggest, and if if this works out well, could be like after the Transformers model be getting utilized or coming to a professional level. This could be one of the biggest updates after that, because the hesitation that most of these companies which are not able to build their models today because they don't have the right infrastructure, because you rightly
Yeah,
mentioned, because they need GPUs which are very costly, which need to be procured from specialized vendors. But with this update, while I know probably we are still not there where we'll be able to run a 150 billion parameter model on this. But as we've spoken about in the past, that we'll slowly start moving towards these domain specific LLMs, which will have lesser number of parameters. This definitely would be groundbreaking research. Shiva. Like you don't have any constraint. I can run it on my mobile phone, right? Or a
exactly.
laptop, right?
R-
So yeah, definitely brilliant news.
I mean,
Uh,
imagine run it on a Raspberry.
exactly. You
Yeah.
have your outcome right in there, right? I don't have to wait, to go to a AWS GPU instance, deploy it and so on, Gravatar instance and so on and so forth. But brilliant update, sure.